Hello, everyone. Thank you for joining the 17th Canadian Underground Infrastructure Innovation Centre webinar, Diagnose-Advise-Treat, a process to rehabilitate manholes. Organized by CUIIC, or the Canadian Underground Infrastructure Innovation Centre, the University of Alberta, and Benjamin Media, the CUIIC Academy offers classes, courses, webinars, and events to help underground infrastructure education opportunities across Canada. The CUIIC Academy webinars happen every third Thursday of the month. Please join us on our next installment, Trench Safety Stand Down, on June 20th. For a full list of upcoming and past webinars, please visit academy.cuiic.ca for more information. CUIIC Academy webinar series covers a variety of different webinars. The next upcoming one and also does presentations and workshops. The 2024 CUIIC Geotechnical Risks and Considerations for Underground Construction Workshop is the next one coming up. It will be focused on, it'll be on May 30th. It's in 2024 at the University of Alberta, and it's designed to equip attendees with the knowledge related to risks associated with underground construction and issues to be considered by geotechnical engineers, contractors, owners, and designers. Attendees will get a chance to earn CEUs from the Engineering Institute of Canada while learning about the most up-to-date advancements in geotechnical investigation methods, addressing geotechnical uncertainty and risk in underground construction, and selecting the most viable trenchless tunneling technology. Attendees will also get an opportunity to walk through case studies implementing these principles, as well as network with industry professionals. To learn more about events, including registration and sponsorships for these opportunities, again, please visit academy.cuiic.ca. Thank you to our 2024 webinar series sponsor, Westlake Pipes and Fittings. I'd like to take a moment to quickly introduce our presenter today, Rob Epp, from a senior manager from infraStruct Products and Services with a rich background in the field of infrastructure development. Currently serving his 6th year on the board of directors as the chairman of the North American Society for Trenchless Technology in British Columbia. His love for nature and commitment to the environmental conservation extends beyond the boardroom, reflecting a holistic approach to his values. It has even been rumored that Rob has a part Chinook salmon DNA, a playful nod to his deep connection with the world of fly fishing and fly tying. Rob, would you like to continue here and start the presentation?
Thank you, Brock. Thank you so much for the introduction. Before I get started, I just want to say thank you to the CUIIC Academy for being so supportive of the trenchless industry, in the past since their formation, and many of their folks came from the University of Waterloo before that. And I also want to say thank you to Benjamin Media. Benjamin Media has been a partner both with CUIIC and with the North American Society of Trenchless Technology, producing trade shows and other events in the years past. And they I'm very privileged to work with such a classy group, and ever so grateful. An amazing amount of work goes into all of these productions, even the smaller ones. And thank you. Good afternoon, good morning, wherever you're tuning in from. Thank you for your time. I'm gonna speak fairly quickly here because time is limited, and the hope is that there's time for a few questions and answers at the end. Jumping right into trenchless, as mentioned, I am the chairman for the North American Society of Trenchless Technology here in British Columbia. My background is actually in excavation and utility installation. And I was employed by, my family had a civil company, and So I started and grew up on the farm, and I started pulling levers when I was quite small, and that turned into I didn't want to be a machine operator. I wanted more. I became a surveyor, and a surveyor led me to leadership, and leadership ultimately led me back to university as an adult, where I got my PMP in project management at the British Columbia Institute of Technology. With that said, now I'm an extremely passionate person about trenchless. I believe wholeheartedly in working smarter, not harder. I will never suggest that we're the silver bullet, that we're going to be out there and we're going to replace conventional cut, cover, rehab, remove, and replace methodologies. But with that said, where we're the right fit, we're a great fit in trenchless. So why trenchless and who benefits? Really, the biggest benefactor of trenchless is the public at large, all of us together. Businesses benefit tremendously from trenchless activities because we're less disruptive to their neighborhoods. We're not digging up the whole street, the sidewalk, the curb and gutter. We're not out there recompacting that concrete curbing, that granular in there for the curb and gutter. We're just less disruptive, and it makes it easier for businesses to work through challenging times when their neighborhood is experiencing rehabilitation. Local residents, the same thing applies. We could work, instead of digging up the whole street, we can sometimes work manhole to manhole. And so, yes, you might be dealing with us in the intersections or halfway down the street, but, you know, I've been told from others that's a lot better than when we dig up the whole street, turn it into a war zone. Traffic from trucks, when trenchless activities, generally speaking, have about 20% of the tooling on site. So we don't have the dump trucks, we don't have the excavators, we don't have as many crew trucks, we don't have rolling compactors and such and such. So that leads us to greatly reduce carbon emissions and fuel not being used, fuel consumption. So, you know, that's good for the environment. And I believe that that's something that we can be proud of, carbon reduction. And, you know, everybody, our governments are setting goals for 2030, 2040, 2050. Well, you know, we don't need any fancy technology here to meet or to help meet some of those goals. We can just change the way we do business and change the way we do certain activities where it's the right fit, and make massive contributions into carbon reduction and fuel minimization. Another incredible benefit is ground disturbance and environmental impacts. The less we have to dig, the less negative impacts that happen, and we also preserve the soil. What am I trying to say? We also preserve sort of the integrity of the soil matrix. It's already at a place where it's been densified, and gravity's been doing its thing for years and years and years, and we don't have to dig that up. Lastly, there is an opportunity to learn more about manhole rehabilitation. Back in February 2023, we did on TV, we did an episode with Mike Rowe, Dirty Jobs, and we took him to a real dirty job. We took him to a McDonald's and we rehabilitated a manhole. So that exists out there somewhere on the internet, and if you were interested, a Google search would probably allow you to track that video down. Real quickly, this is a video that I use in some of my PowerPoints. If I was given 1 hour to save the planet, I would spend 59 minutes defining the problem and 1 minute resolving it. And this might be, he may have said it slightly different, our old friend, but I really do like the motif that this sells here. There are a lot of different options out there, and those options can usually be discovered fairly quickly, but really defining the problem is at the core of being a productive problem solver. Diagnose, advise, and treat. This is a methodology that we've sort of come up with internally. We didn't invent this idea. This was something I'm sure came from the medical industry or something, but we've applied it to our lives and our daily work schedules, and it's definitely paid dividends over the years as it applies to trenchless activities. With that said, across the country, manholes and culverts are aging and deteriorating at a rapid rate. Left unrepaired at street level, these assets can cause concerns, vehicle damage, and potentially expensive and inconvenient replacement efforts. Below ground, damaged manholes can dilute sewage, increase sewage volumes, back up sewage alignments, and make wastewater treatment more inefficient. Bottom line, although an unforeseen asset from a public perspective, the deteriorating assets below ground play a very important role in ensuring the system remains operational and efficient. The challenge for municipalities and end users sometimes the selection of the appropriate rehabilitation method based on the specific needs of the asset, weighing the consequences of doing something versus nothing. To simplify the selection of the appropriate rehabilitation method, this presentation will break down the process into 3 categories: diagnose, advise, and treat. A diagnosis of the problem needs to be clearly defined and understood, understanding the behavior that we're really trying to resolve. With the selection and understanding of the appropriate behavior, this leads us to advise. At this point, what can we recommend? Do we repair? Do we renovate? Or ultimately, do we replace? Again, trenchless isn't always the silver bullet. Sometimes assets have come to the end of their design life. And then treatment, selecting the right technology, the right trade or applicator, be that trade be private or public, with the demonstrable history and the skills required to complete the project, most importantly, safely, on time, and on budget. Before I continue, safely really is the most important piece here. Manholes and culverts and such, in particular manholes, are confined spaces in a septic environment where hydrogen sulfide exists. With that said, there's a certain amount of risk that goes with working in manholes that needs to be treated ultimately seriously. None of us get paid enough not to go home at the end of the day. So the safety piece, I believe I consider this last bullet to be a scorecard. Are we working with the right tradie that has the skills, the experience, et cetera, et cetera? So it's a Cinderella story. How big, is the problem out there? There are a bunch of different studies. The one that I'll be referring to is one that I found from the University of Houston. The manhole is often overlooked and underappreciated, hence making it that Cinderella story. To date, there's a number of research studies on pipeline rehab. These studies predominantly focus on materials and methodologies used for pipeline rehab, for structural, hydraulic, and for economic perspectives. Ergo, there's a wealth of experience and tools out there for engineers to evaluate their options while selecting the material and technology to rehabilitate sanitary sewer pipes and underground manholes, i.e. Underground assets. On the other hand, manholes are a vital part of every sanitary sewer system, often overlooked, as they can be the main source of I&I. That's inflow and infiltration. I&I really is made up of rainwater and groundwater infiltrating and making its way into the asset. Just like Cinderella, again, the manhole is overlooked and underappreciated. But again, manholes are considered windows into the sanitary system, as they're the most visible points for identifying the condition of our underground infrastructure. They also play other vital parts of our sanitary sewer systems. However, for this presentation, I'll be referring to them as our Cinderella. Everything is okay, right, Rob? Sometimes, unfortunately, what can be out of sight can also be out of mind, and it's easy for us to stick our head in the sands or ignore and live a fairy tale, telling ourselves that we don't have problems, when in fact we do. I'm going to use these ratios from the University of Houston, and I'm coming out to you today from Vancouver, British Columbia. The city of Vancouver, by these numbers, has 40,000 manholes. Approximately half of them are very likely to have challenges. 8,000 of them are older than 50 years old, and 12,000 of them are between 30 and 50 years old. Ergo, they're just starting to show some fatigue, much like myself entering my 50s here. The city of Surrey has 31,000 manholes, applying the same ratios. 6,200 of them would be older than 50 years old. 9,300 of them would be greater than 30 and less than 50. And so with that said, 15,000 manholes in the city of Surrey are probably showing some challenges. So here's an example of a restaurant district here in Vancouver. There's a sanitary manhole right in the middle of the sidewalk, right next to the patio on a bright bluebird sunny day. And we can all sort of assume that conventional removal and replacement activities, civil, utility installation activities are going to be extremely disruptive. And this is when, again, goes back to what I said earlier about equipment and tooling and personnel and noise and vibration and everything else. You can see quite clearly here that Homer, mad. Yeah. It also, this slide highlights, we're going to have a hydro excavator, we're going to have a backhoe or an excavator, we're going to have a dump truck or multiple dump trucks for removing spoil, for importing granular. We're going to have compaction equipment. We might have cement mixers coming in to pour bases, and all of these things equate to a longer construction timeline. That said, they provide quite a bit more disruption to the community. They take up a larger footprint, and what's failed before. So we've seen that we installed a beautiful manhole in this location X amount of years ago, will fail again, because it turns out, for whatever reason, there's high H2S and acid in this location that's eaten away the concrete of this underground manhole. And that said, great, we've returned it to its OEM condition here today, but we know that 30 or 40 or 50 years down the road, it will deteriorate once again. With that said, there are other opportunities. So the first one is save money. This went from a $30,000 problem to a $10,000 annoyance. So just focusing very quickly and subtly on the finance piece, this allows end users to literally to rehabilitate 3 manholes instead of removing and replacing one, again, where we're the right fit. So we've saved them money. We're less disruptive because we've got a truck for the workers, and we've got a big trailer, and we're still going to have to use the hydro excavator, but we don't have the dump trucks. We don't have the compaction equipment, and et cetera, et cetera. And once we've applied an industrial coating that we're going to go into in more detail as this progresses, we have become better than OEM. So yes, we've gone in and we've restored the OEM characteristics of this manhole, but now we've applied an industrial coating, in this case polyurea, that protects it completely from H2S and acid, preventing the new manhole wall thickness from corroding as it did in the past. Woo! Often when we open up manhole lids, problems are quite easily identified. So here's a couple examples of those. I talk about I&I, or inflow and infiltration. The photograph on the left shows water coming in from multiple locations. Looks like the pipe penetrations in the base of the manhole are leaking. It looks like the barrel riser joints are leaking. Quite often, one of the more contentious areas of the manhole is that throat, where it meets the street level, and I'll talk about the anatomy of a manhole shortly, very briefly. Then the acid on the right shows corrosion from H2S and acid. You can see that the metallic pipes are corroding. That same acid and hydrogen sulfide is eating away at the dry film thickness, or the original thickness of the concrete manhole barrels, and as this material scales and such, it drops into the bottom, it goes through, it literally gets sucked through our Grindex pumps, or makes its way in the gravity system down to the next manholes, and ultimately a lot of it makes its way to the wastewater treatment plant, where they have to deal with the solids. So, Rob, are we going to reline all the manholes in the world? Is that sort of the answer that I'm suggesting here today? And it's not. We believe there's a much better way, but let's discuss that now. So again, a couple different examples of relined manholes. So here's the meat and potatoes here. Why is Diagnose-Advise-Treat important? If Vancouver wanted to tackle 1% of their manholes in distress, that would equate to 400 manholes per year. If then deployed a full reline option just to make Rob happy, and at a $10,000 average for 400 manholes, that's a $4 million expenditure. However, what we recognize from our experience in industry is that if we apply the D.A.T approach and we recognize that only 20% of the assessed manholes suffer from inflow and infiltration, it's only going to cost $240,000 to bring those manholes back to OEM. If we recognize that 50% of them might suffer from cementatious and channel defects and require optimization or what have you with cementatious and other products, again, we can bring those assets back to OEM for about $400,000. Having said that, 30% of them, my goodness, are about to fail. They will require full rehabilitation, and we look at those numbers for the sake of round numbers. That's $1.2 million. So what this says to us is that we can create a 52% savings and achieve the same result. And that $2 million means a lot to municipalities and end users. That means they can do 800 manholes. That means they can fund a park project. That means they can rehabilitate a water main, or they can remove and replace a bunch of catch basins down the road. What they do with their money is their business. However, what we've been able to provide is a little bit extra fundings. And most municipalities, you know, especially the smaller ones, really have to sometimes wait years and years to prioritize their different repairs. So this little bit of savings, I believe, can go a long way. And we got really good feedback from municipalities saying, you know what, Rob, this approach to problem solving really has paid some dividends for us. Focusing in on that I&I often represents about 20% of the manholes, of the defects within a manhole. The injection of polyurethane resins, which we're going to cover in a second with a little video, is the most cost effective, is considered a permanent fix, and does a great job. So you can see a worker here mobilized into what appears to be some kind of flooded chamber. You can see there's a 6 or 8 inch PVC pipe penetration, and if there was a gasket at that penetration, it's now failing, or if it was just grouted at the time of installation, bottom line, it's failing, water is trickling, or in this case, kind of shooting in. And this is very common. So, well, sort of the causation of what you're seeing here is there's hydrostatic pressure out in the soil matrix that is applying force to the outside of this concrete asset, and where there's give, there's go, and water is sort of leaking in or trickling in. What the worker's doing here is he's drilling a hole, and we're going to inject polyurethane foam into the soil matrix at the leak location, and we're going to use that very same hydrostatic pressure that's causing our leak to hold our patch in place. Because our product, and I'm going to say our, I mean all polyurethane resins on the market, there's two kinds, hydrophilic and hydrophobic. Focusing on the phobics, they displace any water, they homogenize and mix with the silts and the fines, and they literally create a foam patch on the outside of the concrete asset installed properly. And again, that same hydrostatic force causing the leak is now used to repair that leak and stop it from leaking. And the biggest thing out there that destroys polyurethane foam is UV. Underground, this product can last 100 years. Talking again more about the realignment and optimization. Sometimes manholes, you know, this one looks like it was leaking, but that was actually just from washing it free of biologicals to make it safer for the worker to enter. And it's just that the concrete had broken down in the benching. It was probably poured in place years ago, not precast. And a little bit of cementatious work goes a long way to making sure that the manholes that are often used in design for horizontal deflections are doing just that. And we're encompassing additional lines and or alignments, rather, laterals coming into those locations. Then there's the other ones, and sometimes this is that X percentage where, unfortunately, the Cinderella story comes back, and we have ignored, or we've either failed to audit, or somehow missed. And so you can see that hydrogen sulfide and acid have just completely attacked this asset. We've lost half of the concrete wall thickness. We know this because we're down to the exposed reinforcing steel here. So where this would have started out as a 5-inch thick concrete barrel, it is now 2.5 inches thick. That's putting it at risk of failure or it is failing, and groundwater or soil is coming into the asset. You can see that all of this material that scaled off and fell off ended up in the bottom of the asset, clogging the channeling, preventing water and solids from flowing downstream to their final destination, if you will. You know, this one, this is at the absolute top of our priority list. This asset is nearing failure, and failures, normally failure means it implodes, it falls in on itself, and sewage backups happen. And if they happen in the middle of the night, sometimes they're not detected till the next morning, and sometimes people wake up with some pretty nasty things in their basement due to issues like this. And my heavens, it is avoidable. So one of the best ways to go out and sort of understand how big is the problem is condition assessment. And this is a service that we and others offer, consultants, other contractors out there. Condition assessment, really getting a understanding of the condition of our assets. These can be completed in the field. So no confined space entry is required at this time. It's done at the per asset level, and the asset inventory is confirmed, and we can understand some of the characteristics of each asset. We can confirm the depth of the manhole, the diameter of the manhole, the materials of the manhole, most commonly concrete, but what are the connecting pipes made of? Asbestos concrete, PVC, they could be metallic. What size are those connections? And we can confirm that asset ID 33206 is exactly at the provided physical address, or in some cases it's not. And we can correct the GIS and asset management information for the end user. So this little form that we put together on the side, the technician provides his name, the date of inspection, again, the sandfit ID or asset ID number, the physical address, the depth, the riser sections. There's 3 of them, Rob. They're 900 millimeters each with a 12-inch riser on the top. How many interfaces? There's 3 interfaces. We have a clock orientation here that shows that maybe it's just going straight through from the 3 o'clock to 9 o'clock position, or it's entering at 9 and exiting at the 6 o'clock, what have you. And then going into the anatomy of a manhole, we can say, what is the condition of the chimney? Is it leaking? Is the grout work that's been done starting to chip and fall away? Perhaps it's perfect. Maybe it's the nicest grout job that's ever been done. What do the riser joints look like? What kind of shape is the donut in? The donut in British Columbia, we're referring to the lid. How does the benching look visually? Again, the interfaces, are they leaking? What kind of materials are they? And other really, I guess, sort of just covers the condition of the ladder rungs, etc. But maybe there's other, I guess, could also cover an internal drop or something. And maybe the 45 has fallen off the internal drop. This would be the place to note that. So with that information, then we can go back to the office, and in the office, we can review the inspection data and recommend an action plan. That's really important because what we want to communicate to the client is a prioritized list and timeline. My heavens, we found 3 manholes that are at risk of failure today. You guys really need to focus on these 3 first. And you know what, Rob, we don't have a budget for manhole rehab. Well, you know what? You probably want to deal with these 3 in whatever way is possible with the resources you have, and plan to deal with these other ones in the future as your budget or as your funding is provided. The other opportunity it provides us, forgive me for going on and talking so fast, but it helps us recognize systematic issues across multiple assets. It's very common when you come to a neighborhood and you find H2S damage in a manhole. The next manhole you're going to open is probably going to, in line, is probably going to have that kind of corrosion as well. As well, you might recognize surcharging. Where there's surcharging, the opposite of a surcharging manhole is a vacuum, and both of them can provide certain dangers. So at this point as well, we may have identified, you know what, further investigation is required, these 5 or 6 manholes. We need to get in and physically take a look up close and personal at this, that, or the other thing. Maybe take a picture so we can share it with others, and really evaluate if at the end of the day the asset is just approaching the end of its life. Sometimes They are. And sometimes, rehabilitation isn't the answer. Again, under treatment, it's remove and replace, conventional activities. With that said, the 3 typical behaviors that we experience and witness out in the field, and this covers under diagnose, where we are out there and we're visualizing. We have hydrostatic inflow and infiltration, that is groundwater leaking in. We might have environmental exfiltration. I've went to a landfill in the past where they had a leachate system and the manholes were leaking into the soil matrix, and they were happy to. Previously, they did not understand that. They were happy to make that realization, as they wanted to obviously deal with it right away, and they did. And then there's the structural H2S and acid attack that I showed you in the previous slide. So what are my options? The most common option here is point repair, and I call this see a leak, fix a leak. So there's a few different ways that we can fix a leak after we've witnessed it. Portland cements, shotcrete type mixes. There's hydraulic patches, and there's roll-on membranes, and there's the injection of polyurethanes or polyurethane foams, like I mentioned earlier. So we see a leak, we have a leak, and we have some options. What are my other options? Some of our assets might be deteriorated to the point that we need a different option. So that is SIPP, polyurea technology, SIPP being sprayed in place pipe or a pipe within a pipe. There's wonderful epoxy technologies out there in industry. There's CIPP technologies that are out there. And there's CCCP, that's a lot of C's, engineered concrete solution, that is centrifugally cast cementitious products. And we'll talk about that shortly as well for a better understanding. Real quick, here's a chance to understand the anatomy of a manhole. And so we can see at the top of the manhole, we have what's commonly called the throat. And then we can see we sort of have the body of the manhole where the joints exist, or the barrel riser joints exist. At the bottom, we have the benching, and below the benching, of course, we have the footer, if you will. So another option that's out there is mechanical seals for manholes and culverts. Manholes and culverts really share a lot of the same characteristics. One's vertical, one's horizontal. Seals are, I guess, one of the biggest pluses about seals is they're economical. They really are. So you can fix a chimney leak with an internal seal without even going in the manhole. So the reason that's relevant is because confined space entry takes time, and time costs money. So the second benefit of mechanical seals is it doesn't take a lot of training to be able to install these seals. So this is quite often something end users and municipalities almost 100% of the time can install themselves, and they can carry some small inventories, inexpensive inventories, to have on the shelf. So when they experience it, they have a solution. They don't have to reach out to me or someone else to make a repair. They have the tools at their fingertips. Again, they're mechanical. They don't rely on a chemical bond. They're versatile. They come for different diameters, and they're just a wonderful product. There's 2 types of seals I should mention. One is internal, and of course that means that they're applied inside the asset, and the other ones are external. So, external seals can also be used in areas where, when we're installing a new manhole, we can recognize there's groundwater. To install this manhole, we had to run a pump for 4 days. So we know that as we install it and we backfill it, the groundwater is going to come back up. This would be a great time to prevent I&I down the road by applying an external seal in the pre-construction phase. There's also butyl products that can be spray applied, roll applied, or brush applied externally that would accomplish the same task. Advise full structural repairs. So full structural repairs, again, common reasons for failure ultimately is corrosion. The corrosion happens from sulfuric acids, our old friend H2S, road salts, and other acids from external sources, and of course I&I. So again, just to review what's going on with inflow and infiltration is as that water's leaking in, it's bringing soil in, and fines, that's creating voids in the soil matrix. When enough, and those voids are now filling with water, that same hydrostatic pressure that's causing the leak, now filling with water. And as we apply H20 loads up top at street level, it's causing compaction and it's causing failure and alligatoring to the asphalt and voids failures in the soil matrix. Of course, as previously mentioned, the spalling of the concrete substrate is also something. We know that all of this material has made its way into the benching. It's clogged the benching. It's gone through a pump. It's been washed down to the next manhole, the next manhole, the next manhole, maybe down to the wastewater treatment plant, depending on proximity. Where these ultimately, wherever these fines end up, they're going to have to be dealt with either with hydro excavation or evacuation in some capacity. Other I&I challenges we have is through the frame and lid. So again, this is where rainwater is most prevalent at street level, and I&I through the manhole frame and lid can overwhelm sanitary systems downstream. The reason for that is, first of all, we have solutions for that, but the reason for that is that we have 2 3/4-inch pick holes in every lid. That allows us to put a bar in there to remove the lid for entry or inspection. That also is the same as the drain in the bottom of your bathtub. So as water cascades down the road, and if it finds its way to these pick holes, rainwater is now going into your underground asset and watering down at minimum the effluent. And you know, we're paying, municipalities are spending money to mitigate rainwater. That's just that's crazy talk. So how big is the problem? There's, again, a few different studies. I was really just trying to demonstrate a point here. These numbers might vary a little bit, but if, you know, in this case, it's saying that 0.4 of a liter per second inflows through the 2 pick holes with 1 inch or 25 millimeters of submergence. So where there's 1 inch of water running over a surface or into a puddle, there's 0.4 of a liter going in. That said, a 6-inch puddle is letting in 1 liter of water per second. That's 60 liters of water per minute and 3,600 liters of water per hour, 24 hours a day, 48 hours, 72 hours till we get to it after the 250-year storm and deal with it. So British Columbia, we experienced, some of our smaller municipalities unfortunately experienced this a few years back when we had a 250-year storm event, flood event, and their wastewater treatment plants were abandoned. Were overwhelmed to the point where they had to physically be abandoned. The workers had to get in their trucks and drive away because the water just kept coming up and there was nothing they could do about it, and ultimately turned into a swimming pool. That said, all the treated water they were trying to treat mixed with rainwater spread out over the landscape. It was a disaster. Now, there's no easy, simple fixes here, but in some, areas, we can identify, Houston, we have a problem here. These are flood-prone areas. You can see there's obviously, there's a dike in this picture showing that it's holding back water, possibly a pond or a lake, and leading to the high groundwater table in this location. So where they're in floodplains or where floods are known to happen, there is something that we can actually do about that instead of just letting it go into the system. There's other options as well. So talking about the throat of the manhole anatomically, that is one of the more common or most common places where I&I happens. There are solutions. There are EPP grade rings instead of concrete that are tongue and groove, are put together with sealant, and they are bolted to the top of the manhole donut versus a concrete cap to hold them in place. With that said, the frame and lid is also bolted, and it becomes an assembly or a sandwich. And this, without applying any grout, recognizing that this is an area where I&I is common in the top part of the matrix, this is a fantastic solution to mitigate I&I versus conventional concrete riser rings. The challenge with concrete riser rings is compound angles. Roads are often 1% uphill or downhill and 1 or 2% crossfall. So What we have to do when you can see when they're stacked flat like this with a concrete riser ring is we use shims, bolts, nuts, rocks, metal, who knows. And then we try to, like a baker, pipe grout into the voids that are created between these two riser rings to provide integrity and avoid point loading. And that's where those are often the first areas to break down. What's different about these is they have tapers. And so these, they're not shown in this picture, but we have these plastic riser rings that are 1/2 inch at one end and 2 inch at the other. And so we can turn them like on the clock radius to accommodate that 1% uphill. We can put another one on top and accommodate that 1 or 2% crossfill. So simply by rotating our tapers, we can match the grades in the field. Another big benefit, I don't remember how much concrete riser rings weigh, but it's a lot more than 2 pounds. These ones are super lightweight. When you throw them into the back of a truck, they don't break or crack. It doesn't take a forklift to throw a bunch of these in the back of a truck on its way to site in the morning. You can store them out in the yard. They're in your way. Again, you don't need a forklift to move it out of your way. They're just very user friendly. Now, moving on, we also have frame and lid systems that are watertight up to 1 bar. So that is, they'll withstand about 15 feet of head pressure, static head pressure. So they're cam activated, that's saying they lock. And you can see on these, they have handles for removals instead of pick holes. So essentially, this could be installed at the bottom of the swimming pool. I can't imagine in what scenario, but this is a great way, especially combined with an EPP riser ring, like I discussed here, where this could all be bolted together in assembly in a flood-prone area and completely eliminate groundwater I&I. At least from the surface, pardon me, at least from the surface. What's going on under the hood? These are the cam-activated locks, and you can see again for the actual lifting and removals, there's handles. These handles, there's also fulcrums that can be used so a worker doesn't have to use his hands and as much of his back. So slide 37 here, we're going to go through a little animation that shows curtain grouting. This is the curtain grouting is the name we give the process of injecting resin into the foam. Allison, is that animation playing? Here we go.
Prime Practices recommends drilling and filling from the bottom up. To eliminate leaks once and for all, a curtain wall provides a 360-degree protective shield. Job well done. Admire your work knowing you injected long life into the structure, and service is now restored to an acceptable level of performance. Problem solved. It takes products that perform like true
catering and such at street level. So that's this is a very common repair methodology. It's considered a permanent repair. It's very effective, and it's in some cases, depending on the depths and diameters and number of leaks, etc., the most economical as well. So fantastic solution. There's all kinds of there's a few different manufacturers out there. They all make fantastic products, and it's a great solution. Here's another video, slide 38, of an interface leak repair. It's just going to take a second to start here. So interface leak repairs are So again, a lot of reference earlier to semi-structural polyurea systems. You were all already familiar with polyurea. The 1987 Pontiac Fiero was made of polyurea. The only difference between the Pontiac Fiero and what we use polyurea for is that our polyureas, ours and industry's polyureas, are engineered specifically for wastewater. That is that they are resilient to abrasion, and that they are not affected by H2S and acid. So there's SWOT testing and different hydrochloric acid tests out there to verify that information. Lastly, you can see there's wastewater trickler applications. They can be used for abrasion resistivity inside of storm assets, horizontal assets. They're fantastic solutions for wet wells and manhole and septic environments. And there's chemical mixed designs for potable water as well. So often, or sometimes, these chambers are even above ground. Polyureas are a great solution for relining those assets and extending their life as well. So forgive me, slide 40, I supplied too big of a video. I'm not able to play it back to you in this format, but please take a second. It's about a minute and a half, and watch this and go ahead and click on that and watch it. And what you're going to see is one of my guys take a sledgehammer called the Tanya Harding 3000, and he's going to start beating on this brick, and he's not going to hit it very hard. And in the first 5 hits, he's going to break it into 5 pieces. Then he's going to start applying the Tanya Harding to the OBIT covered brick as well, the polyurea covered brick. And really, that will demonstrate for me sort of the resiliency that polyurea can add to concrete or in this case, brick assets. So what we know is that as a concrete or brick asset deteriorates in the field, even after we apply a polyurea industrial coating, it's going to continue to deteriorate behind the scenes. So it's really important that, again, this is a semi-structural solution, that our liners have a large amount of integrity. And you can see, hopefully, right now that he's really starting to smack the heck out of this brick, but it's staying completely intact. Come on. Trying a little bit harder. If any of you make your way to my physical lunch and learns or field demonstrations, I bring hammers and I bring bricks, and people often enjoy taking their frustrations out on my OBIT bricks. So I'm almost near the end of this video. I think I'll wait a few more seconds here and then I'll carry on. But you can see even after the brick is starting to really come apart, there's a lot of integrity left in it as a single mass. And I think this speaks 1,000 words to its resiliency. So moving on to slide 41, I have another slide to show you, and what you're going to see here, this one we'll be able to overlay for your convenience, but what you're going to see here is CCCP rehabilitation. So this is centrifugally cast cementatious product. We have an air spinner that pneumatically spins at 4,000 RPM well underneath of rail lines, in particular in North America. The trains can never stop. It's very expensive, economically speaking, for trains to stop. And so this is one way. And of course, digging across and removing and replacing this culvert under this rail is virtually not impossible, but has its challenges. So this is a good solution that can be achieved. CCCP. And then lastly is structural hybrid. So a structural hybrid is bringing both of these CCCP, full structural rehab, together with a semi-structural industrial coating. And again, restoring the original wall thickness of the concrete. And then because it's failed once, it will fail again, applying a H2S and acid resilient industrial coating to it to prevent future failures. So real quickly, we're just about at the end here. Thank you for your patience. Here's just a little bit of a spreadsheet so we're thinking about manhole conditions. We need to identify one of 3 structural, hydraulic, or environmental behaviors. With that understanding, we can, sort of identify what is causing the distress, and then we can make an absolute recommendation on the most appropriate solution. Before I move on to questions, again, I just want to review that, to propose a solution, we need to define the behavior that we're trying to resolve. Diagnose, advise, and treat is the roadmap for this activity. Eliminating I&I into your system saves an average of $3,000 per year per asset. That nationwide or North America-wide adds up to tens of millions of dollars that are spent every year treating groundwater from I&I. Now, before I go on, there are other sources of I&I connecting laterals and pipes themselves that are leaking at the joints and such. But this is, focusing on what we can do. There are other technologies and solutions for pipelines, but the manhole really is the most visible one and accessible place that we can focus our efforts. I want to thank everyone for your patience, for listening to me talk so fast. There's a few minutes left. If anyone's got any questions, thank you, and I'd be happy to answer any questions.
Thank you, Rob. That was a great presentation. Thank you very much for educating everyone on that. I would like to also thank everybody in the audience for attending. I do definitely appreciate the attendance today, as well as all the CUIIC members listed on the slide. If you're not a CUIIC member, please consider joining. It's a great organization with lots of educational value, and they're on the forefront of the industry. Now, Rob, we do have a few questions here. I'm going to start here. What kind of equipment is used for manhole inspection, and how deep can it typically inspection cover? And then the question was kind of around, will it hit that 40 to 50 meter?
So this person must be maybe from Alberta, where we experience assets in incredible depths. Great question. Thank you for bringing this up. So there all are different types of manhole inspection technologies out there. For the shallow manholes that are up to 3, 4, 5 vertical meters deep, we can lower cameras. It doesn't have to. There are $15,000 GoPros out there. So, but again, it's sort of what we can afford and what resources we have at hand. New CCTV cameras can be lowered vertically on winches. That they can operate in a vertical alignment as well as horizontal. There's fancier systems that employ photogrammetry technologies. I'm actually not in I use a very simple 360 camera that I can embed 360 photographs into my physical reporting, where the viewer can, zoom, pan, tilt, change the orientation of the view. 360 cameras are very inexpensive, under $5,000. But again, for every budget, there's a piece of technology that goes with it. To your point, how do we inspect a manhole that's 100 feet deep? That would probably be more suitable with a CCTV type camera robot lowered down on a cable, because It's an expensive asset. And additionally, one would have to provide lighting at those depths. What I've done in the past is, it sounds a little bit archaic, but I've put headlamps on my CCTV robot just to light, which is a 360 camera, just to light up the substrate so we can get really good image quality. But
Excellent.
lots
Thank
of
you, Rob.
solutions. Lots of solutions. The next no dig or type trenchless trade show that comes to your community or to your province, I would encourage you to go to said show, and you'll meet all kinds of wonderful vendors with wonderful equipment. They're willing and happy to provide you with more information.
Excellent. Thanks, Rob. The other thing we do sometimes see as well is LiDAR scanning in manholes as well.
Yes, thank you. Thank you.
That's another one. So the next question is, for external seals, do you need to literally dig up the sides of the affected manhole?
Yes, we do. And culverts. Yes, we do. So sometimes where we have water infiltrating, let's say it's a culvert, a horizontal alignment, yes, we have to expose that whole joint, be it vertical or horizontal. And so that it becomes not so much a trenchless activity, but sort of something that end users are quite capable of self-performing themselves. But to your point, sir, yes, depending on the depth of said application, if it's over 3'11", shoring, it would be required as well for worker protection.
Excellent. The next question is, based on what you described today, is it applicable for root intrusion?
It is. So the both of the manhole structural solutions and semi-structural solutions are very suitable for root intrusions. What we found from experience is that actually roots magically make their way to sources of water. And a lot of the times when we experience root intrusion into a concrete asset, that's also because they're reaching in there, they're trying to connect with that water. So when the roots are eliminated and an industrial coating is applied to the application, because they're bonded technologies, 9 times out of 10, that eliminates the root intrusion for the future. But being honest, a person needs, again, to thank you for bringing this up. A person needs to acknowledge that there's root intrusion. Really, to diagnose what is the causation of that root intrusion? Why are the roots trying to make their way into this chamber? And sometimes disrupting the soil matrix may also be required, or looking around at trees or what have you that are making their way into these assets. I won't lie and say that root intrusion can be challenging at times. Yes, I've had a few.
Excellent. I think we might have time for one more question there, Rob. I think we might have time for one more question. How well do CAM activated sanitary covers tolerate wintertime salt/grit applications?
Good. They're made of composite materials, really good. Again, maintenance is your friend. So if you're going back out in the spring and you're seeing that there's salt and grit in there, a quick rinse. My manhole rehab vehicles have water tanks and garden hoses in the back. Again, maintaining your equipment, eliminating salt and grit with a simple wash is going to go a long way and prevent it from falling into any interfaces. But as they are very resilient to salt and grit. Yes.
Next question: what solution do you recommend to repair manhole after it's lost half its depth, like the photo you showed exposing the rebar? Is there a point where a manhole is structurally gone and rehab is not possible?
Absolutely, there is a point where not all manholes can be saved. And I really think that this is sort of that level of assessment has to be done at the per asset level. But yes, and what would be my recommendation would be a full structural CCCP, a rehabilitation with a hybrid industrial coating applied on top of that. So let's restore that asset to its original wall thickness, then let's apply an industrial coating to make sure it doesn't happen again.
Perfect. And the next question is, how useful in using the rating system such as NAASCO for assessing manholes?
Can you repeat the question? Yeah, sorry, I'm not reading. There it is.
Just how useful is the rating system such as NASCO for rating?
It's a fantastic language and way of it's fantastic. So It's really up to what your end user, what your client is looking for. But NASCO is a fantastic language for communicating these items. Yes.
Perfect. I'm going to just keep going here, and then we'll try to get through as many as we can here.
I have a few minutes. Yep.
Do your solutions apply to industrial plant manholes?
Yes,
maybe
they do.
Containing hydrocarbons and oily sewers?
Yes, they do. We have different formalizations for the petroleum industry. Correct. Yep.
Okay, we've got a couple more questions here. We are currently doing manhole internal seals for I&I issues. That is lining manhole only 1.5 meters from the manhole frame down. Is 1.5 meters, should it be enough to fight I&I?
Great question. I guess that is dependent on the level of your groundwater. I've seen a fair bit of this lining from finished to 1.5 meters down in northern Alberta, and they seem to be definitely having some success with it. The city of Edmonton has deployed this strategy, and I'm sure a lot of thought and engineering has gone into it. So my short answer would be yes. I guess the long answer would be that is assuming that the I&I is happening only in the top of that asset and less common in the riser joints and around the benching area or foundations.
Okay. The next thing is internal grouting of the upper portion of manholes is no longer there due to freeze-thaw, traffic, general movement caused by separation, which just results in sewer debris. How do these cementitious interior lining product,
yep,
thanks, last adhere, especially in the upper manhole or even lower manhole where there is hydraulic groundwater loading?
Yeah, so they are hybrid mixed designs. How do they stand up? They stand up pretty darn well. But you're right, freeze thaw. I'm in Vancouver, so plus 13 is the middle of winter for us. So I don't encounter this freeze thaw as much as others across the country, personally speaking. But with that said, it's very, very resilient. We haven't had any issues working in Alberta or northern British Columbia where we've applied these solutions.
Excellent. We've got one more question here again. For sealing manhole to minimize I&I, should we seal up including the manhole frame right up to the manhole lid?
Yeah, so I personally believe in a monolithic application. When we do the semi-solution, that is the orange polyurea solution, we take a wire wheel to the inside of the casting manhole frame and lid, and we try to go essentially from the underside of the lip to the very invert of the manhole.
Excellent. All right. I think that's the end of the questions today. Thanks again, Rob, for such a great presentation. Again, for the audience for attending, and to the CUIIC members on the slide. If you have any other further questions around this, you can reach out to Rob here at repp@infrastruct.ca. Thank you again.
Thank you, friends. Have a wonderful rest of your week and an even better weekend.